Hello. Yes, we welcome you back to the PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, tonight we are looking at this question. It's a grade 11 question. The question says that consider the reaction below. This is the reaction we are having where sulfuric acid is reacting with ammonia to give you this salt, ammonium sulfate. And 2.5 kilograms of sulfuric acid was the one which was mixed with 1 kilogram of ammonia. At the end of the experiment, 2.7 kilograms of ammonium sulfate was formed. Then they say calculate the percentage yield. How do we go about this? Okay, here you have to know that in order to accomplish this, we need to determine which of these two, between sulfuric acid and ammonia, is a limiting reagent. Because without that, we can't start. So which is a limiting reagent? So that must be our first mission. So first, what do we do is to determine the limiting reagent. Okay. I need to tell you that the limiting reagent is between these two reactants. So the battle is between these two. What are they? Sulfuric acid here and ammonia. Okay, you have to know that the ratio is, we have a 2 here, so the ratio is 1 to 2. Okay, so you have to find out, what do we know about sulfuric acid? We know the mass. The mass is 2.5 kilograms. And remember, we are supposed to use grams, so it's going to be 2,500 grams. Okay, what else do we need? We are going to determine number of moles. So we will need the molar mass of sulfuric acid. And here you need to know that hydrogen is 1 times 2, which is 2, plus 32, plus 16, but times 4, giving you what? Giving you 98. Okay. This side, what do we know? We know the mass of ammonia. It is 1 kilogram. So if you change this one to grams, it's going to be 1,000 grams. And we are determining number of moles too. So we will need what? Molar mass of ammonia. And this one is going to be 14 plus 1 times 3, which is 3, giving us 17. Okay, that's what we have so far. So the data we have is enough to make us calculate number of moles from the equation which says N is equal to M over molar mass. So when you substitute for M, you are going to say 2,500 over 98. What you get here is going to be the number of moles. Yeah, this is what we have. 25.51 moles. This side is the same equation we are going to apply. N is equal to mass over molar mass. Substitution is going to have 1,000 divided by 17. okay, giving us what? Yeah, giving us 58.82 moles. Okay, after determining that one, then we compare. So we are having our sulfuric acid here, and we are having our ammonia here, and the ratio is 1 to 2. And if we start with this, suppose we are going to use 25.51 moles of sulfuric acid. How much will this react with ammonia? Actually, how much ammonia will react with this? So we find it out through cross multiplication. So we are going to have X equals to 25.51 times 2, giving us, this. So what are these? These are the number of moles of ammonia required to react with our 25.51 moles of sulfuric acid. So in this case, after here, what do you do? Now you deal with ammonia. So with our ammonia, this is what we know. We know that supplied is going to be equal to, what is supplied is what we have here. It is 58.82. And required is what we have calculated for ammonia. And the required is 51.02. So when you get the difference here, supplied minus required, what you get here will determine whether ammonia is a limiting reagent or not. If you find this value positive, like the way it is here, it means that ammonia is in excess. And if it is in excess, it means that ammonia is not the limiting reagent. So it means that sulfuric acid is the limiting reagent. Yeah, so therefore we can confidently say here that ammonia is in excess. Therefore, sulfuric acid is the limiting reagent. This step is very crucial. Very, very. You can't proceed without it. So this is excess. Now we know. And this is limiting. Yeah, so now after determining the limiting reagent, we can now start to determine the percentage yield. And next step is going to be to calculate our theoretical yield. So to do this, the best way out is to have the equation rewritten. The equation is between sulfuric acid and ammonia, giving us ammonium sulfate. So in this case, this is what we have to know. We need to earmark the parts we are going to use. The first one is going to be ammonium sulfate because it's the yield. Next one, we are going to make use of our limiting reagent. Okay. And I need to remind you that in these reactions, the way out is the same. All of them, they move from known to unknown. So for sulfuric acid, what do we know? We know the mass, which is what? 2.5 kilograms. Okay. And we are going to calculate number of moles. So which means that we are going to need the molar mass of sulfuric acid. Here it's going to be 2 plus 32 plus 16 but times 4, giving us 98. So next is to have the number of moles calculated. The equation which is suitable here is going to be N equals to M over molar mass. So if you substitute for mass, which is what? We need to be reminded that our mass is supposed to be in grams. So it's going to be 2,500 or 2,500 grams. Okay, so when you come to substitute here, so you substitute for 2,500 divided by molar mass, which is 98, giving us the number of moles. Yeah. So after getting it, what do we do? After getting it, now we make our comparison here. It's between sulfuric acid, which is 1 here, because the number there here is 1 in the equation, and our ammonium sulfate. Which is also 1. And we know the number of moles of sulfuric acid, which is what? Is 25.51. So if the ratio is 1 to 1, it means that this one is also going to be 25.51. So now we know the number of moles of our product, our yield. So the next step is to list everything we know about our yield. Remember, the product is ammonium sulfate. So what do you know about it? Now we know number of moles of it. It is 25.51 moles. Okay, and we want mass. So which means that we are going to need the molar mass of ammonium sulfate. Yeah, this one is given, let us see. Nitrogen is 14 times 2 plus hydrogen, which is 4 times 2, plus sulfur, which is 32, plus oxygen, which is 16 times 4, giving us this 132 grams per mole. Okay, after that, then we can proceed and calculate our theoretical yield. You have the number of moles, you have the mass, and you have the molar mass. So this equation applies. What's the equation? Number of moles is equal to mass over molar mass. Number of moles is 25.51. Mass is wanted, but the molar mass is 132. Okay, if you cross multiply here, you're going to have your mass as 25.51 times 132, giving you that mass. You're giving us this 3,367.32 grams, which if you convert it to kilograms, it's going to be 3.36732 kilograms. what we have here is the theoretical yield. And we need to be reminded that percentage yield is equal to actual yield over theoretical yield times 100. Okay, so when you come to substituting this one, what do we have? Actual yield was given, it is here. It is 2.7, so it's going to be 2.7. And the theoretical yield, it is 3.36732 times 100. So what we get out of this one is going to be the percentage yield. Yeah, so that is it. Our percentage yield is 80%. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we appreciate your time, but we urge you to subscribe. It is for your own benefit, and don't miss it. See you next time. Bye-bye.